Okay, good evening, everyone. So thanks again for attending this our first online class for 2021. So I'm Jeffrey. Okay, so today we will have this RoboCup at Home Education Online Challenge 2021 online classroom for Open Platform. So Open Platform is a customized robot platform that is the main category of our competition in Online Challenge 2021. And today is the first class, so I'm very happy to see quite good response. You all punctual and attended this session, so everything should be fine, the link and everything. And I just checked, you should be able to see the screen. So I have shared my slide on the screen, so you should be able to see the screen. And also my webcam is on, so you know who is talking to you. And also I hope you can hear me clearly. All right. So it's quite quiet here, so everything should be fine. Okay, so first thing I would like to say thanks to our sponsor, because we actually running 4 track of online classroom this time for 2021, and 2 tracks is actually in collaboration with Turtlebot and also Masswork, which is also our technical partner in this event. Okay. Right, so I'm Jeffrey. I'll be your host and also the speaker today. And later on, I will invite some engineers from Turtlebot to speak to you for today's topic. So today the first one is service robot development. And today the first half class is about this system setup. Okay, so let me start with some logistic arrangement. Right. So just in case that your colleague and everyone, okay, so as a reminder, please turn off your microphone and also your view cam, okay, unless you are invited to speak, or else in other time, please mute your mic and also refrain from turning on your camera, okay? Right. So as you can see on the screen, so we have the meeting room and it is in the QR code form, because the Microsoft Teams link is very long, so I put it into a QR code so it's easier. So just in case any of your colleagues still on the way or still finding how to actually join this session, so you can send them the link or you can send them the online classroom page, which is we have the link and also the button over there for you to join. Okay, so today we're supposed to have 2 classes. The first half, which is 7:30 to 8:30, we will have the class, which is we will talk about system setup. So I'll give a brief introduction, then I will tell you what you need to set up for your system, because this whole online classroom is supposed to be a hands-on. Okay, and then you are supposed to follow us to do some hands-on development along the way for your learning. Okay, so the first half we will focus on what is the system that you need to set up in order to follow the development, and you can use this system for your development for your competition. Okay, right, and then the second half we will start at 8:30 to 9:30. Then we will focus on the topic of ROS basic. So I'll give you some introduction about what is ROS, just in case that anyone in the list is new to this environment and also development. So just a brief introduction, because I need to settle everything in an hour. So and also to tell you how to get started with ROS, so that you can prepare for the next class to start developing application with ROS and also for your service robot. Okay, then we have 3 links down there. Okay, so the first one is the link for the online classroom. Hi, Professor Julio. Okay, just as a note, a reminder for you, please maybe I will let you to turn on your webcam later on during the interaction session. Okay, so turn off your microphone and also your mic until we are told to do so during the interaction session. Okay, right. So the first link is okay. So this one is quite important so that you know where to find all the information. The first link, the online classroom, is the link that you can open our web page, that you can find all the information, particularly the time and also the content of our online classes. Okay, so just in case you want to attend the paper class tomorrow, and also, but tomorrow is for the Chinese track. and also Wednesday and Thursday. So we will have open platform and standard platform, and also we will have in 2 languages. Okay, so one is in English and one is in Mandarin Chinese. So if you would like to find the time for each of the session, you can go to this online classroom link to find all the details. So we will have all the dates and also the link how to join and so on. So it's over there. And also, if you want to get the materials, okay, so now currently we only put very limited information in involving the materials of the course. For example, like the video that taken now, and also the PowerPoint slide that we presented during a class. It will be posted out, okay, in the second link. So if you go to the second link, which is this year we collaborate with Robot for All, which is they host all our course materials. So please head over to the second link to find all the materials later on. Okay, so you need to give us some time to update. Okay, we need to record, we need to process, and we need to put up. So currently it's not really a lot of materials over there, but over the time we will slowly put up. So you can refer back anytime, as long as you just need to like create a free account over there, and you can just enroll to the course and you can get all the materials. So anyone who have problem signing up or enroll to the class for free, please contact us. Okay. And then the last one is the class group. Okay, so this class group is also another function in Robot for All that not just hosting our course materials, but you also can have some interaction with us over there. For example, if you have questions you want to discuss with us, over there we have a forum, and also we have other facilities over there for you to ask us questions or discuss with other teams. Okay, right, we have the event there and so on. So just head over there and slowly will get used to the interface, and you can explore and how. So the class group purpose is for us to interact. Okay, just in case you have some question about the competition or you have some question about the class, please post up your question over there and we will discuss over there, right? Not just us, but also the whole community will be there. Okay, so before I start, the last reminder is for the privacy. So this whole session will be recorded, the video will be recorded, and we will publish online after this. So please, again, refrain from turning on your microphone and also your view cam unless you are told to do so. Okay, all right. So I have finished all the logistics. I would like to start the class. Okay, so I will spend like about 20 minutes to cover all the theoretical part, which is like an introduction about what is service robot, what we use in R&D and so on. But in the second half of this first session, later on, we will have some demonstration to show you how to set up the system. So I would like to go very fast. So don't worry, because like you can look back this PowerPoint slide later on, just to give you a brief introduction so that later on you can focus more on the step-by-step how to set up your development system. Okay, right. So for us, when we talk about service robot, okay, I refer to this basic service robot component. Okay, so over here we have 5 parts that we focus on during our development. So the first one is for the interaction. So we call it the robot mouth and the ears. It's similar like human. So it's for you to interact, whether to interact with another robot or to interact with another human and so on. Okay. Service robot, the important thing is the interaction. Okay, then the second one is the eye, which is the visual perception. So all the things that we use to sense around the robot, whether it's an object or whether it's the furniture or the scene or the other, human. For example, you need to track someone, you need to find someone. So we use our robot eyes to see all these things. Okay. Then the robot need to have the legs, which is for the autonomous navigation. This is very important, or else the robot can't move around and cannot do anything. And then the next one is robot arm. So this one is for the robot able to do some physical manipulation, whether to pick up something, to point some direction, to do some simple movement during interaction and so on. And lastly, of course, the brain, which is the AI part, the machine learning part, and also over here, we are not limited just to onboard computation, but also we connect to the cloud so that we can connect to our cloud computing and big data facilities. Okay, so these are the 5 basic components in Service Robot. Okay, so just to show like what we have, or what we do during the competition is like we will have a lot of tests to see how the robot can interact with the surrounding, okay, in terms of the interaction. And over here we focus on the technology development in speech synthesis, recognition, either offline, online, and also face recognition, face expression, and so on, right? Then the second one, just I told about the eye. So you can see over here, the technical part is like we try to get information whether it's in a 3D form. So we can have the point cloud, or we use the laser that we get very accurate and very far distant and so on. So these are all the data that we need for visual perception. Okay, right. Next one. Okay. So in this visual perception, we will cover some part. For example, like we will show you some OpenCV stuff to do the image processing, and also our system. After you set up, you will have some. You will also able to do some deep learning object recognition stuff. For example, like using the YOLO base or using OpenVINO and so on. So you can recognize object. You can recognize hand movement, gesture, and so on. Right, and this one is the practical use during the competition, which is we need to use the face recognition that you develop in the competition in order to identify people. Okay, so that is part of the competition. And if you would like to know more, we actually like extend all this development not just for the competition, but in my lab also we actually extend this deep learning stuff and also this gun technique for various kind of visual research. Okay, so next part is about the navigation. So this one is very typical, I think, like everyone understand. For example, like you have the roam bar, which is able to roam around your house without banging into something or without stuck somewhere, and know how to move around safely and efficiently. Okay, so how to do that? In this online classroom, we will learn the basic understanding on how to build a map, the 2D map, and also how to do the object recognition, object avoidance, and so on. And then we will learn something about this, how to use the arm together with the wheel in order for the robots to move around and grab something. Okay, so this is what we call the mobile manipulation. And if you combine this with the arm with the autonomous navigation technology, you can actually do very, how to say, complex research work that involve a lot of things. For example, like this, this is for the mobile manipulation that we discussed about the reachability, the how to position the base so that you can grab better, and so on, right? Okay. And lastly is the brain. So just now, as I said, our computing power is not just limited to the parts where we put on board, but we also connect to the cloud so that we can do a lot of processing using a more powerful server up there. And for example, like next week, we will talk about the speech. So part of the speech is we're using the online version, which is we actually send the sound and process in the cloud so that you can get the information processed by the server instead of processed by the robot itself. Okay, and we also extend to a lot of things. For example, like in this class also, you will see some simulation stuff, which is we try to have some virtual environment for the robots so that we can do more learning. For example, like learning how to actually do some tasks, do some experiment in a virtual space so that you can save a lot of time and cost without actually need to run a lot of physical experiment. Okay, so that is all about the R&D part that you can do with Service Robot. So the next thing I would like to introduce is like, so how to get started, how to DIY a Service Robot with whatever mean that you have by following this class. Just assemble some very simple hardware that you can start your AI and Service Robot development. Okay, so we started with a very simple mobile platform, which is very similar like the Roomba, the floor cleaning robot. And then on top of that, we built some structure, which is a very simple wood and also pillar structure. Then we put a very popular RGBD sensor, and also you can add some 2D laser sensor in order for more accurate sensing. And then we have a very simple arm that resemble the industrial arm, so they actually work with the same theory. So with just this very simple arrangement, we can start our service robot development. And over here, we use a very simple and also popular platform called the Turtlebot 2. So from there, I will use this as the reference in this class to explain to you how to build all this thing. Okay. Okay, so if you would like to know more about the specification, you can look through, like these are all the component, basic component. Basically, all these things you can buy from the shops, off the shelf, and so on. It's nothing very complicated, and also the budget is not very high in order to get all those things. So these are all consumer grade. They are almost consumer grade products that you can get easily. And also, most of the software they introduce in this course will be open source course, open source software framework that you can download actually from the internet, and also you can set up. Okay, but later on I will show you like how we set up the software environment. Okay, then from there you can actually reassemble and also redesign the hardware and also the software configuration of the robot in order to tackle different kind of problem or task in the competition or in your AI robotics application. Okay, so over here we will use this as our reference for the coming class. Okay, so with very similar like previously already explained. So the 5 parts is over here for you to actually put everything together in order for you to develop service robot application. Okay, and then if you are looking for open source resources, so we already gather a lot of resources and we put up on the websites that we try to maintain, and also some of the reference website. So for example, like if you were looking for the OpenCourseware, all the materials, not just the one that introduced in this track, but also some of our other information, you can head to our website over there under the Learn section. You can find more information over there. And for the online classroom information, just now I said this link, so you can find all our materials that we develop in online classroom. Then support wiki, you can go over there for more in-depth step-by-step guide. Source code, okay, so all the source code, open source code that we use in this class will be up onto our GitHub repository, okay? And you can also see some cool video. And this video, I will recommend you to head over to our YouTube channel to have a look, because like it also have all the videos of our past competition that teams actually build up very nice video to demonstrate their development. Okay, and to start off your development, you can use our development source code example, which is the last one that covers all the speech, vision, navigation, arms, and also application over there. That this is the most fundamental things that you can start off to develop your service robot. Okay, right. So for this online classroom, it's very, how to say, resemble to our content in our hands-on, because previously we actually do hands-on workshop, but because of the COVID, we cannot see each other, and also we cannot access to our hardware. So we try to minimize all the hardware requirement and also all the interaction, physical interaction, and then we try to come up with a set of learning materials for you to able to do your development with a very minimal hardware with you. Okay, so in this online classroom, what you need is just a webcam, okay, or maybe you can use some other sensor that resemble the RGB sensor. And then for the mobile platform and the ARM, we will use the simulation base. Okay, then all you need is just a laptop, computers, and speaker and mic. And this is very typical for as long as you have a PC, you have all these things. Okay, right. And the software we use open source Ubuntu. Later on, we will introduce you one very simple tools that you can set up this system easily without go through all the dual boot and stuff. But yeah, on basic, we need all these things. Okay, so the Ubuntu system as the OS, then on top of that, we have the ROS, which is the software framework for our development, and we use various open software for example, like for your speech, for your vision, and so on. Okay, so all this software you can obtain freely from the internet. Okay, and the way how we actually show you our demonstration, basically we have a few configuration that you can design. So for example, like if you want to set up everything on your laptop, so the laptop itself is actually also your system for your robots. Okay, so that is the configuration number one, which is you have the Linux on your laptop. Okay, then for the configuration number two, just in case, like for example, maybe you have a Raspberry Pi or you have a PC that dedicated for your robots and so on, and then you use another PC for other stuff, then you can use configuration number two, which is over here we use a lot. For example, like in this online classroom, I will use TeamViewer to connect to my robot to show you what is happening in the robots instead of just using my robot system to actually do this online classroom. Yeah, because like to run all the Teams and all the PowerPoint on my robot system is very messy. Okay, so I will use a configuration number two that you can also try to set up for your system. Okay. And then if let's say like you are using configuration 3, okay, so this one is when you work with your teams. Okay, so when you work with your team and then you want to have how to say, an environment that belongs to you but not messing up with the environment in the robot, so you can use this configuration. Okay, so your robot will have the Linux environment, and also your laptop or your PC will have a secondary Linux environment. So with that, you can actually do remote development without actually rely totally on the Linux environment on robot. Okay, so maybe you don't understand like all these three because I explained very briefly, but over the time, slowly you understand this. Okay, so you just need to follow us closely later step by step to set up your system, and then slowly you will know like all these things. Okay, right. Okay, I'm running out of time, so I need to be a bit more faster. Okay. Okay, so for the system that you need to set up, okay, so we need this Ubuntu system as the OS. And different from last year, we actually upgraded our system to Ubuntu 18.04 because version 16 already like end the LTS, which is end of service. So which means we need to upgrade all our system to Ubuntu 18 in order to have a more well support by the Ubuntu system. Okay, right. So Ubuntu 18.04 LTS is the version that we are using. So if just in case that you are choosing which version to go to, please use this version so that everything that we show you, we already like tested and make sure it's run on the system. Okay, so this Bionic Vivia system is the one that you need to set up if you start from scratch now. Okay, so the link over there, you can find the information. If you want to download the image, you can go to the release page and so on. And if you want to know how to install, Ubuntu have a very comprehensive tutorial to show you how to install. Okay, but maybe it's not so simple for you to install if you don't have any experience or extra PC for you to install, because like you might already have your Windows or Mac system in your desktop or in your laptop. Okay, so over here, Jupyter Robot has been very generous to actually prepare a virtual box image that contain Ubuntu, ROS, and all the essential software, everything already like packaged together in the image. And all you need to do is hit to the Google Drive, download. Okay, the download will take some time because it's very big. I think like about 15 gig. Okay, so it will take some time. So don't rush and download now. You just follow the whole class and then you can download after this. But make sure you finish this this setup before the next class. Okay, right. So all you need to do is later on you just go to the first link for the Google Drive. You can download all the file for the image, and also there's a guide over there inside there to show you how to do it. Okay, so as a reference, if you want to know like how to use VirtualBox and how to link to your image in your VirtualBox, you can go to the reference link over there. Okay, I just choose the first one on Google search, so you might refer to other guide as well. So the idea is how to set up a VirtualBox in order for you to run the image. Okay, right. But for any one of you that would like to have a better performance, because like VirtualBox still run on top of your Windows or Mac, so your system resources is actually divided by half. Some part to the native OS and some part to the VirtualBox. But if you would like to have a full performance for your Ubuntu system, then you can consider to set up a dual boot. Just in case that if you have Windows 10, you can use the link. Again, this is the first link that I got it from Google search, so it's not necessarily this is the best one, but you can search all other. There's many materials to show you how to do the boot up, to do the dual boot. But just as a reminder, dual boot, if you are not careful, it might erase your original OS. So do it only when you know what you're doing. Okay. All right, and always back up before you do any of this. Okay, but the important message here is like before the next class, you need to set up this Ubuntu system on either a VirtualBox or dual boot on your laptop system. Right. Then after you finish set up the Ubuntu system, the next thing you need to put in is ROS. Okay, so I think all of you know what is ROS, but just in case you don't know what is ROS, I will explain in the second half of today's class, which is the next hour, right? And the ROS version we are using this time because we already upgraded the Ubuntu system, so we also need to upgrade the ROS version, which is compared to last year. Now we are using the melodic system. Okay, so you can hit to the link over there to the ROS wiki website to download and also to look at how to install ROS melodic. And this one is very straightforward. Okay, and then the tutorial is quite easy to understand. It's just a few steps. It's very simple. And also the second link is the link that I think is very important. After installation, I will recommend you to look at the tutorial. Okay, so at least for the beginner level tutorial is very helpful if you can have a look before you jump in and start your development. Because like if you start your development without knowing what is ROS, so it will be very confusing. Okay. Then after the Ubuntu and also install ROS, the next one you need to install is Turtlebot 2 package. Okay, but this is optional. Okay, so in case you are in this class just want to learn about, so for example, like computer vision, for example, like robot vision or the speech interaction and so on, you don't really want to know about like autonomous navigation and stuff. You not necessarily need this Turtlebot package, but I will recommend you to install because like you can learn a lot more things and you will integrate your vision, your speech and everything into one robot that can further develop into a service robot. Okay, so I will recommend you to go through this. But the installation for this melodic system, so the Turtlebot version, you also need to find the version for melodic, which is currently on the website. It actually stopped at Indigo. Okay, so you can go to the GitHub page over there. It shows you a way to install melodic on your Turtlebot 2. But if you are using the VirtualBox option, the first option that I said just now, when you install your Ubuntu system, you actually can skip the ROS and also the Turtlebot package because everything already done in the VirtualBox image. Okay, then the rest of the setup, I just put down the link just in case, because I don't know what sensor you are going to use, whether you have an old Kinect sensor or you have the new Astrea sensor or you have the webcam and so on. Yeah, so different things. You can refer to different driver and how to set up all your hardware. But of course, like if your hardware or the things that you are working on is not available over here, and also is not working with the system that you install it, so feel free to actually contact us for discuss further. Okay, then after you finish all the installation, you need to set up the workspace. So that's why I recommend you to go through the tutorial, because I think the first tutorial or the second one is how to set up your workspace. So you need to set up your workspace. And why I need to mention this here is because like for our RoboCup at home education repository, GitHub repository, we actually have a series of sample source code. okay, open source sample source code that you can use. So that is the sample ROS code. So that is the few step for you to download, git clone our sample code and put in. And also because this class also connect to some class later on in the plan that we will have some development using MATLAB. So just in case that you have some interest to use MATLAB for your development, we also have some sample code that you can download. You can do it now or you can do it later. But just to tell you where is the sample code so that later on when the class need all this code, you know where to find, okay? And also down there got a disclaimer just in case that for the new installation, you might face some problem during catkin make, which is when you build with some problem. So you just follow the guide over there to get rid of the error. Okay, so these are some of the Git and GitHub stuff, which is I don't want to explain now because like you will only use it later on for your Git development or when you set up your GitHub. Okay, so you can refer back to this page after the class. Right. So that's all the first half materials over here. Okay, so my timing control is just nice, so 30 minutes. So I have another 30 minutes. I would like to invite our collaborator from Turtlebot to show you the demonstration. So now you will see like the step-by-step demonstration how to actually set up the virtual box image. Okay, right. So can I have representative from Turtlebot? I think like David and also Max. Are you there?
Yes, we are here.
Okay, so I will pass the session to you. So for the audience, please pay attention to whatever in front of you because like we are going to show you. So just now what I say is just the theory part. So the next thing that you're going to see will be the practical things that how to set up the virtual box image. And this is very important because like by next week, you are okay, we will assume if you want to follow the class, you have this system with you, okay? Right. Okay, so I'll pass to you, David and Max.
Good evening and good morning to everyone, and thank you, Professor Jeffrey. Turtlebot is honored to help RoboCup at home education to organize online classroom for this year. Just like almost the same as last year, we will use a VirtualBox, which is a kind of virtual machine for the environment of the open platform. And now I will show the procedures to how to install the VirtualBox for the Windows 10 system. So as you can see, this is a screen of the Win 10 system, and I have already set up install the Oracle VirtualBox software like this. And we also have already installed the extensions for the VirtualBox Manager. So next, I will extract the package from the Google Drive and install the virtual machine. And if you download the files from the Google Drive, you can find you have 4 files. And the files name ends as 001 to 004. So if we use the software to extract the files, for example, we use WinRAR to extract the file. So we just need to open the 001 file, and we can see the whole file with the name like this. And you can choose this file and extract to your folder. I have already extracted the file, so I just show how to choose the file. After that, you can import the virtual machine to the VirtualBox software. I will show you how to import. After you open the VirtualBox Manager, you can use this import, and you follow the guide to import the system. And the first step is to choose the file you extract. And for me, I store the file at okay, I will extract again. extract to disk. Okay, select the first line. So the reason why we spread the files to 4 parts, the reason is that the limitation for the single file of Google Drive, the whole file is very big. You can see it's almost 15 GB. So you need to find a place to store the file, and you also need to find a place to store the extract virtual machine. Okay. Now we input and select the file from the this one, and this been open, and the next. So this is a brief description about this virtual machine file, and this is a place. This is a place where you will store extract the virtual machine file. So this is you need about 30 GB for this virtual machine. So I will change to the others file folder. So I will choose to E and this one. This means choose this folder and keep the settings as recommend, and just click generate new MAC address for all NAT adapters. Just change to this selection, okay, and input. Please pay attention to the disk space for the VirtualBox software. It will use about almost 30 GB for this Jupyter Sim VirtualBox software. So for this VirtualBox, we use Ubuntu 18.04 and Rose Melodic. Okay, just wait a few seconds. In the Google Drive, we also provide a file to help you to install the VirtualBox Manager and how to input the Jupyter Sim. So never mind. Okay, and before you start the this VirtualBox virtual machine, you need to check the settings for this one. For example, we collect the settings, and we need to make sure this invalid setting detected should be cleared. So we will find out which one to make this warning. So you can click the different tab to see if there is a warning. So main reason for this one is maybe lies on the numbers of the processor or the size of the base memory. So this is green part is the allowed number for the base memory, and the processor is higher than the recommended number. So for me, I set up this virtual machine. I use 6 processors. This is a virtual machine CPUs for the system. So we need to drag this one to the green maybe green part of this area, and there is no warning again. So this is we need to check before we start the VirtualBox machine. So click OK, and we can click Start. Just wait a few seconds. We will start the Jupyter Sim system. Okay. In this Ubuntu 18.04 and Rose Melodic, we have already set up all the almost all the package for the online classroom. Actually, this package is almost the same as we set up in the real robot. So if you want to study something like those and want to prepare for the competition, you can use this virtual machine. And I will show you the difference between the virtual machine and the real robot. So because this is the virtual machine, so the processor is shared with your robot, with your computer. So if you launch something like Gazebo and Avis, maybe it will be very slow, but it depends on the processor power of your real computer. Now I will show you one example about the performance of this virtual machine. I will launch a demo for the Gazebo and Avis. So this is a demo for the Move It application. So Move It is always used for the arms and robot to plan the action of the arm. So I just started this demo. There is some warning. Never mind, this is okay. And this launch automatically starts Gazebo and Avis. So I will show you the performance in this virtual machine. And as you see, the FPS, which means the frame per second, is very low. And the Avis also shows this number. Here is 8 or 9, less than 10 FPS. And the Gazebo is also almost less than 5 or 6 FPS. So I will show you the Move It result, something like this. And let's see what happened. Failed. I will replan and execute. Oh. Failed. Okay, replan again. Maybe this reason is I use just 3 processor of the CPUs. Let me see. We can use another one. Uh-oh. I will restart the demo. So this maybe happened if you use too complex applications, such as you need to start a Gazebo and Avis at the same time. Gazebo 没有起起来。Okay, I will change the setting of this VirtualBox. 我刚才用了几个 CPU？ 你下午有几个？ So for if you need to change the setting, you need to power off this VirtualBox and click setting and system processor. I just add one processor. Okay, and restart again. So this is a very special demo because we almost use the max power of the computer to run the Gazebo and Avis at the same time. So for most of the applications, just for example, for the image processing or for the navigation, it will not too complex like this. Okay. Let's see. This is Gazebo. This is Avis. And we need to wait for the information, which means move it is okay. Just wait a few seconds. Okay, maybe something is to connect movement 4 seconds. Okay, I have a backup plan. I have plan B. Because we start Gazebo and Avis at the same time, it's very difficult for this VirtualBox. So I have split the launch to two parts, and we just need to launch the first part. We make sure the Gazebo is working or not. Okay, this is the launch for the Gazebo and new tab. Second part. Okay, let's check the. You can see the arm is action as we planned in the Avis. So I will show. So because this FPS is very low, so it's almost hard to so this is how the VirtualBox working. Okay, I will shut up the program and I will show you if how we fix this problem. Use special equipment. Okay, and because we have already know the speed of the VirtualBox is very low if the computer is not very good enough. So we have product special equipment to power off. And 我把这个画面给你。我换一个画面。Now you will see Leave camera. This is a computer we just used for the VirtualBox, and you can see this one. 拿起来，放在手里头。This is a Jupyter I/O box, which means it's a very small box, but we set up the system in this box, and this box is connected with the computer via USB 3.0 interface, and we need to restart the computer. 直接从机表亮进来，你刚才没进去是吧？没进那个。We will restart. So during the start procedure, we need to select the different part to start the system. We need to enter the setup interface to select the different part for the boot. Okay, there is a boot named Ubuntu Jupyter Education. Okay. This is the same computer we just use. We don't need to install the Ubuntu system in this computer. We just connect this box to the computer, and we can start a real Ubuntu system with absolutely same software in the system. So you can see the interface is the same as we just see in the VirtualBox, and we will show you the performance of this one. 跑一下那个 ，Ctrl 加加 ，Ctrl 加加。 直接跑那个，对，直接跑那个。Rose launch Jupyter Robot Arm Move It Demo 直接对第二个的。Okay, this is absolutely same launch file. We start Gazebo and Avis at the same time. So you can see it's very fast, and the FPS is almost 10. 规划吧。So we can it's very fast than the VirtualBox. Okay, and the next I will show you the performance of the real robot. So why we need to why we set up this VirtualBox? The reason is we want to help us to study the rules and the how to develop the software for the program for the computation. So if you have a real robot, something like the Turtlebot or something like the Jupyter robot, if you program on the VirtualBox or even this I/O box, you can just copy the program to the real robot and see what happens. So I will show you the real robot. Okay, this is the this is the interface of the real robot. 搬过去，把摄像头搬过去。刚才我大概就是上了。Okay, this is a real robot. I will show you the same result if we used for the software. 哎，我得用这个。So because this is real robot, so we need to 开电，开底盘电。Start the base of the robot. 手臂电看一下。The file is different as we used in the Jupyter Sim because this is a real robot. So this is the interface of the real robot, and we use the same method to plan the action of this arm. Okay. This is the always interface, and the always shows the real position of this arm, and we also use this one to. For example, up, plan and execute, and catch. You can also drag this ball to the different position you want, and you can drag this circle to make the different position of the arm. Same as you see in the VirtualBox. And we also have the ability to plan the action of the head, I mean the head of the robot. You can see we can set the position of the head, and it will turn to the position you select. And we can also show you the image of this camera. I will show you the image, and so this is the image where the robot captured with his top camera. Okay. If I change the position of the camera, it will show the real-time image of the camera. Okay, thank you, Professor. Thank you, Jeffrey. That's all for the demo. Jeffrey. Jeffrey.
I hope you can hear me, right?
Yeah, I can.
Okay. So it's a very impressive demonstration. I hope like you have some idea, because like so what have Jupyter Robot has shown is like first they introduced the VirtualBox, so which means you can run your development using the VirtualBox environment. Then they further show you like VirtualBox have some limitation, because like we all understand that VirtualBox actually only able to use like half of what you can what your machine can give. And after that, they show you the comparison with their very cool AI box, the small Jupyter I/O, which is how you can use the same laptop and have better performance just by adding the AI box. Then you compare with the real robot, okay? And I think it's a very nice system that they integrate everything together so that you can have your development, whether it's on a VirtualBox or on using the improved performance Jupyter I/O. And what I think is very nice is like whatever that you develop in this VirtualBox image, or whether the system that provided from the Jupyter I/O, you can actually run everything port easily and without any changes on the real robot. So I think this is a very handy thing that whether for education or for real development is very useful for us. As a developer, I feel that this will help us a lot in the development, where most of the time you might not able to use your robot for the development, whether it's during charging or in use and so on, or when you are back at home, you didn't bring your robot with you, so you can use this environment, right? So, but that is provided you have the hardware and so on. So you can actually assume that the VirtualBox environment that you have is similar to the real environment that is running a robot. So which means whatever that you develop, the practicality of your application is there, right? So which means you can actually run the thing on the real hardware as well. So without like, okay, maybe you want to test on some simulation, then after that, when you want to port to the real world, you want to port to the real robot, then you need a lot of transferring, and then you need to readjust your parameters and so on. But this gives you a very unified environment that you can do everything together. So I think it's very nice. So thanks, David, for the very interesting demonstration. And our time control is very good. So now it's 8:30. We cannot afford to have a break, but I would like to switch to the second topic, right? So I hope, okay, someone actually raised your hand. Okay, so yeah, before I start, if you have anything you want to ask, yes, Alberto, if anything you want to ask me. Yeah, you can either send a text in the message box, or you can just turn on your mic and say out what you want to ask. Someone actually put out your hand, right? Alberto, are you there? I saw your hand. Are you going to ask something, or you accidentally press the hand icon? All right, so if let's say you are not responding, then I'll proceed, because like we have a very tight schedule here. A lot of things that we need to cover within these 2 hours. So the next hour, we will talk about this ROS basic. Okay, so I hope you can see the screen. So I put back the screen now, and then also my webcam is running, and also I'm talking. So I hope like all of you can come back from the demonstration, and we will now tell you the second part of the story for today. Okay, so for the second part, we will introduce you what is ROS, and also I will show you some basic thing how you want to get started with ROS, but maybe you can't do much thing. Okay, so I'll do some demonstration how to do all those things. But so what you need to do is like later on, I will tell you you have some assignment. Okay, so for the topic number 1, which is just now, you actually have an assignment. I will explain the assignment later on at the end of the session. So you will have 2 sets of assignment, one for the 1A and then another set for the 1B. Okay, so but I will explain at the end of the class. So now let me start with the ROS basic introduction.